In this video, I'm going to be working out a classic physics problem, a roller coaster problem, where we take a look at different heights, velocities, analyze the energies, and we're going to solve for things like potential energy, kinetic energy, velocity, and height. All right, now when we're taking a look at a roller coaster, one of the first principles is that your first hill should be your highest hill so that you have a high amount of energy to get through the ride. Now, as the roller coaster moves through the ride, it's just converting potential energy to kinetic energy back to potential, and it has various amounts of both depending on the height of the roller coaster at that particular moment. Now we have three different spots at h equals 12, h equals 14, and a velocity of 8 at the end. Now for an actual roller coaster, of course it's going to lose some energy because of air resistance, because of friction, sound, and all other types of energy. So we're taking a look at an ideal situation where our total energies just stays completely consistent. All right, with that being said, if we take a look at our first hill here, we have a height, so we could use our first formula to find the potential energy. So we're going to take the mass of 500 kilograms, our constant g of 9.8, and our height of 20. If we find the product of those three, then we get our potential energy pretty easily. Toss in our calculator, we get 98,000 joules. Now at this point, although it's probably not completely at rest, it's probably pretty close to it. So we're going to say that the kinetic energy is equal to 0 joules at the top of our very first hill, and we got our potential right here. So if we want our total mechanical energy, which I wrote out over here, ET equals the potential plus the kinetic, we simply add 98,000 plus 0, which is obviously 98,000 joules. Now that first hill is going to be a key calculation because it gives us a very important value, which is this one right here, our total energy. We know that total energy is going to be consistent, so whatever the potential and kinetic are at every point in the roller coaster, they should sum up to 98,000 joules. All right, so here's what we're going to do. We are going to take that idea, and then we're going to solve for the kinetic energy, the potential energy, and the velocity for this next hill. So for this one, we know the height is 12, so we're going to do a similar calculation. We're going to take the mass of 500, our g value, which is always 9.8, and our height of 12. Again, we just toss that into our calculator, and we get a velocity, or excuse me, a energy of 58,800 joules for our potential energy. Now from there, we want to solve for our kinetic energy. Now here's the part where people may get confused. They see the kinetic energy formula and they see 1/2 mv squared, so they want to use a velocity, but they can't. So all you have to do is, if you know that the potential and kinetic sum up to the total, and the total is 98,000, then we only have one unknown variable. So our total is 98,000, and we know the kinetic and the potential have to sum up to that value of 98,000. So we just subtract 58,800 from both sides, and then we get our kinetic energy. That comes out to 39,200 joules. Okay, that's going to be the method to find our potential energy or kinetic energy if we don't have a height or velocity. You're going to take a look at the total mechanical energy, do a tiny bit of subtraction, and then you'll be able to solve for your unknown variable. In addition to that, if we want to solve for the velocity of the roller coaster, now we can go ahead and plug in that value. Kinetic energy equals 1/2 mv squared. And if we want to complete that calculation, what we're going to do is we're going to do two steps. 1/2 times 500 is 250. So I'm just going to go ahead and divide both sides by 250. And then I get a value of 156.8. Okay, and then my final step is I'm going to go ahead and square root that value, and then I'll get my velocity, and then my velocity comes out to 12.52 meters per second. All right, so that does it for our red calculation. So let's go ahead and clear a little bit of space for that one and then get to our next hill. Our next hill's calculation is very similar to the one we just did, so we'll kind of just use this as another repetition to get a little bit more practice. Okay, again, we're going to use our potential energy formula to get our potential energy value, which is just mgh, and then we're just going to multiply those in our calculator, and this time we get a slightly higher potential energy because its height off the ground is a little bit greater. This is 68,600 joules. So without saying, if it's at a greater height, I automatically know that there's more potential energy, therefore there must be less kinetic energy to keep that total energy constant. And then again, just like last time, if we know that our total energy is 98,000, and we know that that is the sum of our kinetic and potential, all we have to do is set this up, and we know that if we subtract 68,600 from both sides, we can get our kinetic energy value, and that's going to give us 29,400 joules. Okay, from there, if we wanted our velocity, we can go ahead and use that KE value and then plug it into our kinetic energy formula, and then do two steps of algebra, which is 1/2 times mass times velocity squared. What I typically like to do is what I did earlier, combine my 1/2 with the mass, which is 250. So this is going to look the same as before. Divide both sides by 250. Square root it, and then I have my velocity, and now because I'm at a greater height, I should have less velocity than the 12.52 I had earlier, and I do. I have 10.84 meters per second for this hill. All right, now moving on to our last hill. This uses the same principles as our first couple hills, but this one we have an unknown height. So what we're going to do is, since we have the velocity, we can go ahead and find the kinetic energy, which is 1/2 mass times velocity squared. And then we get our kinetic energy of 16,000 joules. Okay, so that seems fairly small, so I'm expecting the height to be sort of larger. Now I'm still going to use the same idea as I did earlier. I'm going to take my total energy and then set that equal to my kinetic plus my potential. This time I have my kinetic. I'm going to subtract 16,000 from both sides, and then my potential energy is going to come out to 82,000 joules. All right, so that's my highest one yet. So I'm expecting the height to be greater than the 12 and 14. So if I plug this in, then I have 82,000 equal to mg times h. So I can go ahead and divide these over to the other side. Okay, so I'm gonna divide by these numbers over here. They're gonna cancel out, and we're gonna just take the quotient of these numbers, and then I get a height of 16.73 meters. So that was correct. It is the greatest height out of the previous two of 16.73 meters. All right, so main idea by far is a conservation of energy. And in this case, we are neglecting friction and air resistance, and we're saying that the total amount of energy stays constant, and it's just split between potential and kinetic. Anytime there's more height, there's more potential and less kinetic, so more height and less velocity. Anytime it's at a lower point in our roller coaster, we're going to have less potential, more kinetic, so less height and more velocity. And in some cases, here's a little trick you can use. I'm going to throw in here. If it goes all the way from the very top and is all potential energy and changes into all kinetic energy, what you can do is you can actually cancel out the mass, and the mass is actually insignificant, and you can do a little problem solving for there. As some final tips, if you are actually building a roller coaster in your physics class, you want to make sure that first hill is significantly taller than the rest of them. It doesn't necessarily have to be triple the height, but you definitely want to give yourself a lot of energy to start off with. You want to make sure all of your curves are as gradual and rounded as possible, so no real steep slopes. Like if you see this one, it's gradual. You don't want to go very steep and then right back up again. That's going to be hard for a little cart or marble to complete. So if you have nice smooth curves and you have a lot of energy in the beginning, and you make sure track isn't way too wide or way too skinny, you should be pretty successful in completing a roller coaster project. So I hope that was helpful to you in completing those calculations. Thank you for watching and listening.